Hey everyone, Mr. Hauk here. In today's video, we're going to be looking at graphing hyperbolas. By the end of this lesson, we should be able to graph a hyperbola given an equation, and given a graph of a hyperbola, derive its equation. So, in our notes here, we have some general information related to hyperbolas. We know from the previous lesson that hyperbolas have a general form equation and a standard form equation. And just to kind of quickly go over what those are, we know the general form equation is very similar, almost identical to the general form equation for an ellipse, only the x squared and y squared variables, one of the two is going to be negative. For the standard form equations, we saw that the standard form equations help us determine what kind of a hyperbola we're dealing with, whether we're dealing with a hyperbola that opens up or down, which is if the leading variable is y, or a hyperbola that opens left or right if the leading variable is x. We also saw that A is half the length of the transverse axis, and we know the transverse axis connects the vertices. B is half the length of the conjugate axis, where the conjugate axis connects the covertices, and H comma K is the center. Also remember, very important, that unlike with ellipses, A does not have to be larger than B for a hyperbola. So our goal here is, given an equation, we want to be able to graph the hyperbola. In order to do this, the first thing we're going to need to do is identify the center and plot it. Then we're going to need to find and use A and B to plot the vertices and covertices. This will allow us to draw the central rectangle, and when we connect the diagonals of the central rectangle with some lines, that's going to give us the asymptotes. We also want to identify if the hyperbola opens up and down versus left or right. Remember, if x comes first in the standard form equation, the hyperbola opens right and left. If y comes first in the standard form equation, the hyperbola opens up or down. Then finally, we're going to use the asymptotes from the central rectangle and the vertices to sketch the hyperbola. Let's go ahead and see an example. So we'll begin with this example on the left. We want to sketch the graph of the ellipse. It says ellipse. This should say hyperbola, by the way. This is a typo. So let's go ahead and scratch this out and write hyperbola. All right, sketch the graph of the hyperbola given by the equation x plus 3 squared over 4 minus y plus 1 squared over 16 equals 1. First thing that I think is important to identify is what kind of hyperbola we're dealing with. Notice that x is the variable that comes first on the left here, so this is a left-right opening hyperbola. Okay, next let's go ahead and find the center, the a term, and the b term based off of the equation. From the equation, we can see pretty easily that the center is going to be -3, -1. So I'm going to go ahead and plot the center right here, -3, -1. We can see that the a term, which is the square root of the left denominator, is going to be 2. And the b term, which is the square root of the right denominator, is going to be 4. Now, since this is a hyperbola that opens up left and right, the a term is going to be going, we're going to be applying the a term left and right of the center. So left 2 and right 2, that's going to give us our vertices. The b term is going to make up, is going to help us plot the conjugate axis. So we're going to go 4 up and 4 down from the b term, right there. And now this is going to allow us to draw the central rectangle. So let's go ahead and draw a little rectangle going around the center using the vertices and the covertices. And then what we want to do is we also want to plot or sketch in some asymptotes connecting the diagonals of the rectangle. And this doesn't need, remember, we're sketching here, so it doesn't need to be 100% accurate, but try to make it as accurate as you can. Notice that, again, the asymptotes are going through the diagonals and also through the center. Then all we need to do now is go ahead and sketch the hyperbola using the vertices, which are right here. The vertices are created with the a values, and then using the asymptotes as guides, we can sketch the graph of the hyperbola. And this is what a rough sketch of our hyperbola would look like. Looking at our next example, and again, same typo because this was copy and pasted. Ellipse, let's go ahead and scratch that out and write hyperbola here. We're trying to graph a hyperbola. And notice this time the equation is given to us in general form. Now, rather than going through and showing all the work for general form, I showed the work at the bottom of this page. I'm going to go down and pan towards the bottom. If you need to write down the work, make sure that you pause the video to write down the work, okay? But here's the steps to convert from general to standard form. All right, right down here. Notice that after converting from general to standard form, we end up getting y minus 1 squared over 16 minus x squared over 25 equals 1. So I'm going to carry that over up here. So we got y minus 1 squared over 16 minus x squared over 25 equals 1. So first thing I want to do is go ahead and identify if this is a hyperbola that opens up down versus a hyperbola that opens left and right. Notice that the y variable comes first on the left. So this means this hyperbola is opening up and down. Once more, the reason this is important is because once you've identified the way the hyperbola opens, that's what you're going to use the a value for. You're going to move in that direction from the center. So the a value, or first let's look at the center. The center, we just have x squared over here. So the center is going to have an x coordinate of 0 and a y coordinate of positive 1. The a term is going to be the square root of the first denominator, so square root of 16 will give us 4, and the b term will be the square root of the second denominator, which will give us 5. So we start by plotting the center, 0, 1. We know that we have an up-down opening hyperbola, so let's go up using the a value, up 4 and down 4 from the center. 1, 2, 3, 4. 1, 2, 3, 4. And then the other direction is going to come with b. Let's go 5 to the right and left. 5 right there. 5 right here. And just like the previous example, let's go ahead and sketch in the central rectangle using the vertices and the co-vertices here. Also, just like the last example, let's go ahead and use the central rectangle and let's connect the diagonals through the center to create the asymptotes. Okay. Now, we know that the vertices are these points right here, because that's where we used the a value from the center. And again, using the asymptotes as guides, then we can... Looks kind of bad. Let me redo that part. Go ahead and graph the hyperbola. Okay, so that's generally that's a good sketch of the graph of the hyperbola. It shows all the different parts, the center, the vertices, the co-vertices, and the asymptotes. All right, so the next kind of examples that we want to look at are examples where we're going to be given the graph and we want to write the equation. So here's the general strategy. Again, we want to identify the center, HK. If we're given the central rectangle in the graph, identify A and B from the central rectangle. Remember, A is going to be half the length of the transverse axis, which connects the vertices, while B will be half the length of the conjugate axis, which connects the co-vertices. If you are not given the central rectangle, but are instead given the coordinates of the foci, we will need to find B by using the equation c squared equals a squared plus b squared. Then we're going to plug in AB in the center HK into the appropriate hyperbola standard form equation and simplify. And when we say the appropriate hyperbola standard form equation, that means we have to identify if the hyperbola opens up down versus left right. And then we pick the equation based off of that. So let's look at our first example. We can see that in this hyperbola on the left, that this is definitely a left-right opening hyperbola. So I'm going to take note of that. This is left-right opening. Okay, so now we need to identify the center, the A term, and the B term. The center we can see is at the coordinate 2, -1. The A term, we're going to look at the distance from the center to a vertex, and we can see that distance is 3, so the A term is 3. And for the B term, we're going to look from the center to a covertex, and the distance there would be 4. Now, since we're dealing with a left-right opening hyperbola, we have the equation, the standard form equation, x minus h squared over a squared minus y minus k squared over b squared equals 1. Plugging in our coordinates, or plugging in the pieces that we have, we're going to have x minus 2 squared over 9 minus y plus 1 squared over 16 equals 1. Okay, so once you've got these pieces here, A, B in the center, and you know the direction of opening for the hyperbola, it becomes pretty simple. All right, in the next example here on the right, notice that this time we're not given the central rectangle. And the reason that that's significant is because if you don't have the central rectangle, you're not going to automatically know what the B term is. So the strategy here is going to be, let's find the A term. And we can find the A term using half the distance of the transverse axis. We're going to find the C term using the distance from the center to a focus point, and then use the equation c squared equals a squared plus b squared, plug in A and C that we just found to solve for B. So a couple things though that we want to identify real quick. We can see pretty clearly this hyperbola is opening up and down. And let's go ahead and find the center. So the center is right here, this yellow coordinate. This is going to be the point -1, +3. Additionally, we can see that the distance from the center to a vertex is 4. So the A term is going to be 4. The C term, which is the distance from the center to a focus point, we can see is going to be 5. So the C term is 5. But we don't know what the B term is. So again, we're going to use the equation c squared equals a squared plus b squared, excuse me. And let's plug in 5 for C and 4 for A. So if I plug in 5 there, c squared would give me 25. If I plug in 4 for A, we're going to get 16 plus b squared. 25 minus 16, so subtracting 16 from both sides, we get that 9 equals b squared, which tells us that b is going to equal 3. Okay, and now that we know that A is 4, B is 3, and C is 5, and we also know the center and the fact that this hyperbola opens up and down, we can now plug in the pieces into the proper standard form equation, which is, by the way, y minus k squared over a squared minus x minus h squared over b squared equals 1. Plugging in our pieces, we know that y minus k squared, well, k is 3, so this will be y minus 3 squared over a squared, which would be 16, so y minus 3 squared over 16 minus x plus 1 squared over 9 equals 1. All right, so we can see pretty straightforward. It's all going to boil down to, can you find the center? Can you find A? Can you find B? Do you know the direction of opening? All right, next we're going to have a couple of problems where we're going to be given specific information, and we're going to try to write the standard form equation of the hyperbolas given that information. In this first problem, we want to write the standard form equation of the hyperbola with vertices -10, 10, and -10, -4. So that's for the vertices. And we're going to have the endpoints of the conjugate axis, -5, 3, and -15, 3. So a couple things real quick. We're given the vertices. We know the vertices connect the transverse axis. If we're given the endpoints of the conjugate axis, well, the endpoints of the conjugate axis are the covertices. So I just wrote down that we had the vertices here, and we had the co-vertices, negative 5, 3, and negative 15, 3. And what I decided to do is give a very rough sketch. This is not drawn to scale in any way. It's just a rough sketch, okay? But the purpose that it serves is that, number one, we can kind of really pinpoint where the center is going to be and really kind of see where the center is going to be. And we can see that the center, based off of this very rough sketch, well, if we know that for the co-vertices, they have y values of 3, and for the vertices, both have x values of negative 10, then the center, which is where they intersect, is going to be negative 10, positive 3. Okay. Now, let's talk about the information that we can get just from these pieces of information alone. Knowing that the vertices are negative 10, 10, and negative 10, negative 4, well, a couple of things that tells us. It tells us that vertices are the endpoints of the transverse axis. Okay, transverse axis. Which, by the way, if we think about it, if we're trying to find the length of the transverse axis, well, the x values are staying the same, so we're finding the distance between the y values. Well, the distance between a positive 10 and a negative 4, this whole distance is going to be 14. So the length of the transverse axis is 14 units. Now, if the length of the transverse axis is 14 units, then the a term, which is half of that, is going to be 7. Additionally, we know that since the vertices and the transverse axis are running parallel to the y-axis, and again, these are the vertices here, we know that this hyperbola is going to open up and down. So this is an up-down hyperbola. Okay. Now this is pretty significant because you remember the information that we need to write the equation. We're going to need the a term, so I'm going to circle that. We're going to need the direction of opening, and we're going to need the center. So really the only thing left for us to find is the b term. And we can find the b term using the co-vertices. So remember, the co-vertices help us determine the length of the conjugate axis. Okay, and when we look at our little rough sketch here, the conjugate axis and these co-vertices, well, the y value is the same, so we're just finding the distance between the x values, negative 15 and negative 5. And the distance between negative 5 and negative 15 is going to be 10. And let me put length equals 10. Let's be consistent. So 10 units in length for the conjugate axis. And we know that the b term is half the length of the conjugate axis, so the b term is 5. And now we have everything that we need to go ahead and write the standard form equation. So the standard form equation for a hyperbola that opens up and down is going to be y minus k squared over a squared minus x minus h squared over b squared equals 1. Plugging in our pieces, y minus k squared, that's going to be y minus 3 squared over a squared, and we can see that a squared is 49, so y minus 3 squared over 49 minus, let's see, x minus h squared, that's going to give us x plus 10 squared over b squared, that's going to be 25, equals 1. Okay, and there's our standard form equation that meets these criteria. Vertices at negative 10, 10, and negative 10, negative 4, and endpoints of the conjugate axis, negative 5, 3, and negative 15, 3. Next problem we want to look at is a problem where, again, we want to write the standard form equation of the hyperbola. We're given the vertices are 12, negative 7, and negative 6, negative 7. And this time, we're given that the central rectangle has a perimeter of 72 units. So let's think about the information that we can go ahead and gather just from the vertices. So vertices, we know the vertices connect the transverse axis. So let's write that down. So this gives us the transverse axis. We know that the length is going to be, let's think about it here. We can see the y values are staying the same, so we want to find the distance between a positive 12 and let me go back to this, a positive 12 and a negative 6. Well, think about a number line, right? Positive 12, 0 somewhere over here, negative 6 here. The distance between negative 6 and positive 12 is 18. So length is equal to 18. And if the length is equal to 18 of the transverse axis, that tells us that the A term has to be 9. Okay. The other thing this tells us is that since the y coordinates stayed the same, and we were finding the distance, between 12 and negative 6 for x coordinates, think about what that graph would look like. Over 12, down 7 would be something like this. Negative 6, negative 7 would be something like this. And we can see that the transverse axis would be horizontal. So we can see that this is a hyperbola that's opening left and right. Okay. And the other important piece of information that we can gather is actually the center. We know that the center is going to be the midway point of the vertices. Well, again, think about it. We can already tell that the y coordinate of the center is going to be negative 7. So we know the center is going to be something negative 7. Now, on a number line, we want to find what's the halfway point between negative 6 and positive 12. Again, think of negative 6 as over here. We have 0 over here somewhere. We have positive 12 over here somewhere. Well, if the distance from negative 6 to 12 was 18, well, half of that distance, which will get you to the center, would be 9. And if we just count 9 in either direction, from negative 6 or positive 12, like if I go 9 in this direction, that would bring me to a 3. Or if I go 9 to the left of 12, that'll still bring me to 3. So we can see that the center is going to be the point 3, negative 7. You could also just have used the midpoint formula with 12, negative 7 and negative 6, negative 7, and you would have got the point 3, negative 7 anyway. So thinking about the pieces that we still need, we have the A term, we have the direction of opening for the hyperbola, and we have the center. So what we're still missing is the B term. And we're going to have to use the perimeter of this central rectangle to find the B term. So I went ahead and drew a rectangle, and we already know, the central rectangle tells us the distance of the transverse axis and the distance of the conjugate axis. We already know the transverse axis is 18 units long. So I went ahead and put 18 on each of these sides right here. And we know that the perimeter is 72 units. So if we can find basically the width of this rectangle and cut that width in half, then we can find the B term, or basically the distance from the center to a covertex. So let's think about our perimeter formula. We know that perimeter is 2 times the width plus 2 times the length. We already know here in this case that the length, so that we know the perimeter is 72. We also know the length is 18. And 2 times 18, that's going to be 36, so 72 equals 2w plus 36. Let's subtract 36 from both sides. This tells us 36 equals 2w. And dividing 2 on both sides, we get that the width is also equal to 18. Now, thinking about the central rectangle, what this is really telling us is that all sides of the central rectangle are 18. And you could calculate, if you added 18 4 times, you would definitely get 72. And remember that, thinking about a central rectangle, the center to the sides give us the A and B term. Well, we already know the A term is 9, so the center to a covertex is going to be 9 as well, because we cut this width in half. All right. So again, this 18, that's the length of the conjugate axis. Go ahead and write that down. And we know that taking half of the length of the conjugate axis means that our b term is 9. And now we have everything we need. We have our a term, we have our b term, we have our center, and we know the direction of opening for the hyperbola. Being a left-right opening hyperbola, that means that our formula is x minus h squared over a squared minus y minus k squared over b squared equals 1. Plugging in the coordinates for the center and for a and b, we're going to get x minus 3 squared over 81 minus y plus 7 squared also over 81 equals 1.